Hey, what's up, YouTubers? Today I'm going to be going over how to properly test an iPhone battery. If you don't know what the charge cycle or the capacity of the battery, it could be slowing a lot of people's phones down. So replacing the battery, and you want to make sure you get a good battery and replace the customer's battery with a good battery too. So basically, this little feature, this tool sits here and charges the actual batteries and tests them. So you obviously have up to iPhone 7, 7 Plus. Be the same thing with the newer ones when they update the software. And this is the actual adjusted current of the machine. And you're not going to know the instructions how to use it because it's all in Chinese. So basically this one is the like a little USB connector, like if you want to hook this up and you plug it in here, and you can actually power up the phone inside the actual phone instead of removing the battery from the casing. It's a nice little tool. So what we're going to do is basically we're going to put a battery on this. We're going to test a couple batteries here just to show you. You can see it working and non-working and close to working batteries. And then we're going to open a new one and see what a new one is. So when you get new batteries in, you want to obviously test them before you put them in a phone, customers. So you don't send them on their way and they come back, hey, the battery's not working or something like that. So this one is going to be this one's going to be an iPhone 4 here. This is a manufacturer date. Some of these batteries are older than we are. I don't know what this one is. This one's 2015. So 11/30 of 2015. That's when this battery was. And this is an iPhone 4. So we're going to plug it in here. Pretty sure it's a 4. No, this is actually, excuse me, this is a 4S, so I haven't worked on these phones for so long, so they're old. But you can see the lights lighting up there. We can plug this in the machine, so we can turn the machine on first. We'll plug it in. And you know how you heard that, just that little beep? I fixed that little beep because that is one annoying loud little tone where it just goes really loud in your ear. It's just horrible. And especially if you're going to be working with it, you don't want to be hearing that beep all the time. I don't know why they would come out that loud of a beep. If you guys are the makers and you guys are watching this, please tone down the beep in these machines. I actually had to modify my scope because of the beep. The continuity beep was so loud on it. I just do not like the loud beeping noise. So I modified it with the flashing noise. This one, I'm probably going to modify this device to flash instead of beeping. So when you can see the flash, you know it's done. And that'd be a lot more easier than just dealing with the loud crapping beep noise that you hear from these devices. So as we can look here, we can see we have the information here in time. How many times it's been charged? 954 times. Efficiency 63%. So I would consider this a bad battery, just because look at the efficiency and look at what it's designed to hold. and the capacity that it's going to hold is 900 out of 1400. So that's pretty bad. Voltage 4.5. So we obviously got this charged up. Current, temperature of the battery and the chip. And the main key thing is when you're purchasing batteries off eBay, you're dealing with other vendors and stuff like that from China, it's always nice to get original iPhone 4S battery. So it's going to tell us if it's original or not, or it's fake, or it's going to have a real serial number. So if we go to charging, and we'll hit stop charge, usually you'll see if it's charging over here in the blue. This one's already fully charged at its capacity it's going to charge at. So you can also go down here and we could see 945 times charged, right? So we could go down here. Let's try. I've never tried it before, but let's try time clear. Let's clear it. It says clearing. Oh, now it just went down to zero time cycle. Obviously you want to do that, but you could do it. Now let's go back over here. Oh, look at it. It said it's charged 0 times. Now these are how people can sell you like refurbished batteries, and you get the battery in, you think it's OEM and it's original and it's brand new, it's never been used because it's 0 times, but come on. Somebody could use a machine like this and reset the time, counter time of the battery itself down to 0. We just did it. And it's still going to show the same percentage. So if you get a new battery in and you're wondering, okay, it has 0 times charge, but it's at like 60, 70% or 80% efficiency, then you're going to know there's an issue there. So what we're going to do is try to test another battery here, and you could charge it. Like I said, this one's already charged at its max. If you want to change the ESN or serial number, not ESN but serial number, then you got the counter times. So what we'll do is we'll grab another battery, disconnect this one, now for example purposes I wanted to use this battery. This is common in the iPhone 5, the 5C, and some of the 5S's. We got an expanded battery here. This is a manufacturer date of 2013. So that's an old battery, but still expanding. And it's still expanding. So let's try to hook this up. And that's going to be a 5S, I believe. We'll have to just try it. Alright, so it's a 5S. But we get nothing on it. We'll restart the device. And it says please connect battery. Well, the battery's connected, so we'll try it one more time. And you want to press down on this. Oh, there we go. Alright. Now you can see this right now. This says, yeah, I'm pressing down firmly on it. Let's see. It says connect battery. Non-original battery. So you know why you guys are getting like the exploding batteries when you get these fakes out here. Let's see if we just get this connect. Alright, so we can't even get none on here. Let's see if we get a charge. Can't get nothing, no data. And non-original battery. So if you guys can see, that's a non-original battery. Reading non-original battery. So if you get a battery and you're going to sell this as to a customer or something like that, you do not want to sell them a non-OEM battery, just because of stuff like this, exploding batteries, or you're going to see it come down, come back to you like 5-6 months to a year down the road, like, hey, my screen's popping out, I wonder what happened. So you kind of want to not use fake batteries. And charger cables too, also. I can't stress that enough. The charger cables ruin the TriStar chip, they ruin the batteries. So don't use fake cables on iPhones, especially if you're spending a good amount of money on an iPhone. You don't want to use those cables. So we got an iPhone 4 here. This is a 4 battery, so we're going to connect this one. Just going to get a read on it. Okay, now this one's saying non-OEM, which I don't believe that one. Probably reading the old phone or something. See, just exactly what I said. It's reading the old data. So we can see we have iPhone 4 here, and we have original battery. Original. And we have 630 charge cycles, 95 efficiency, or 95% efficiency. And then we have the design capacity, 1400, and we have 1300. 4 volts, and the temperature and the manufacturing date. And that would have been 2010. So this one is actually, that I want to say is, yeah, 2010. And you see in the other battery that we had, that one was newer than this one, and this one hasn't exploded or capacity. It has a serial number. So, and if we went over here to charge cycles here, we hit start, we hit charge. And if it's charging, you'll see it charging over here, it's a milliamps, but you can see that we have the exact milliamps here. So that's the capacity that the battery is going to charge at, tops. So let's take a new battery out of picture. Well, here. Oh no. So charging, I forgot to tell you guys here. So if we want to charge this battery, you need to plug the cord in, which is janky. I don't understand that, but so now we see charging here. So that was my bad, you guys, but yeah, we see charging here now in the blue, and we can probably see that go up. See 70, 76, 77. And we'll look at the charge cycle here. We'll give this a second just to show you. And you can see you have the amperage, the voltage, and the current. Or the percentage, I mean. Or current. And voltage and percentage. So that's what you have on there. So we have a pattern there, a grid pattern. Now you can see it just spiked downwards. So we get no more power to there, so that's capacity it reached. And charging, so you know that's capacity. That's the most it's going to charge at. Even if we hit stop, start charging. Alright, there it's charging again, right? I mean, in theory, you probably could jumpstart a battery and just get it going again, in a sense, with the low capacity, but you don't want to do that. Alright, so now that dropped down. So that's obviously, that's capacity of it, 93%, 95%. So that would be considered basically a good battery in a sense. It's not 100%, but it's 95%. It's pretty good, especially an old battery like that. I mean, I said 2010, so can't really find a manufacturing date on this, but I'm gonna go off that because by code they gotta put their manufacturing date in the system, so chipped. So we got another board here. So we got an iPhone that's in the board. We want to test it without removing the battery, right? So we don't want to go through all the hassle of that. So we'll plug the cord in. Then this is an iPhone 6. So we'll put the board in here like this. It's the other way, actually. It's this way. It's upside down, I'm not sure. Can't remember. Let's see. So we have it like that. We have it connected. And then we're going to hook the data cable up to it. We got power. We got reading battery. So this says original battery. And you can see this one says efficiency. That's why I'm saying you could reuse the batteries in some phones. And you want to, just for recycling purposes. So we have less batteries going to landfill. A lot of people sit there and replace an iPhone battery and it doesn't need to be replaced, but alright, so we got 75 times. This is not a lot on a phone battery. Like you can see we had 900 or 800, and then we had some that were at like 400. But I mean, that 400, that's the iPhone 4, and that's a strong battery. I mean, you could tell it's a strong battery. Like you could pick it up, the weight of it, how solid it is. Let's try it. I don't even, if I have another battery around here, let's grab another battery here. Just not as hard. Hear how hard that is. So better quality built with the older ones. So we got another battery here, we can test this one, but so you can see this one's 0% charged. So what we're gonna do is we're gonna go over here and we're going to capacity. See the capacity? 1734, 1751. So not that off. This is a good battery, 99% efficiency. So this is a really good battery. Now you want to actually check out the charge cycle on this too when you're running this battery. You don't want it to be too low or too high. You kind of want it medium, but upwards slant. So you're gonna adjust the amperage on it, depending on what kind of battery you're working with. But we're gonna let this charge just to show you what the meter looks like. So we're gonna let this go for a couple of minutes. Maybe I'll speed this up, maybe not, but we'll let it go. You see we're at 10 milliamps, 11 milliamps, and we're at 3 again. You're going to want to watch the jumping of this. Because it was at 10 milliamps and then it jumped back down and jumped down below. So, and really the only reason I use the battery charging system like this, is even doing a customer's phone, and I'm working on their phone. I want to charge their battery and have them with a charged battery when they leave out of the store, or when they pick up their device they have a fully charged battery. They don't have to worry about charging. So when I'm working on a phone, prior to that, I'll put that phone on charger and let it charge up the battery, so we have no issues with the battery or anything. So we got 21 milliamps, so we got 1% there, you can see. And usually like from 10 to 15%, you can take a reading on the battery to find out that battery is good or not. But pretty awesome device that you can sit here and actually use the charger to charge the battery that's inside the case of multiple phones. But obviously this is going to be our charging percent going up to the 100. Then we got our amperage. Then we got our voltage that's going to it. So you kind of want to see this. And you want to make sure too, when you're messing with the iPhone batteries, that this percentage does not go up too high. So if it goes up too high, then you're going to have issues with the battery. That's why I say, like, testing batteries from certain vendors is a nice thing, so you can tell if you got OEM battery or not. In a second here, we'll take this battery apart here. This is a 5S 5C. Give iPhone new life, MP battery. So I'm not giving them a shout out, nothing. They're in California, but I haven't had no issues really with their batteries. This is not a paid sponsor advertising for this company or anything whatsoever. But you can see that I've been dealing with these people for a while. I've been buying their batteries from them, and they're fast shippers. So, but besides that, we're gonna test their battery under real life and see if this battery's been charged, recycled, repackaged, or we're gonna see what the percentage on it is and how it charges. So this is sealed, never been opened, and I try a couple different vendors every once in a while. I've never had any problems. Maybe one battery I had defective from them, and that was it. But besides that, I had good luck with them. So we'll test that one here in a second, just to show you a little video, or not the video, but the diagram of what's happening right here. And you can see kind of like how these are meeting. I mean, if somebody knows this a little bit better than me, this machine, feel free to comment or anything like that. But I'm pretty sure when it wants to meet up in the halfway range with the voltage to be a good battery, and then go up to 100%. Obviously, some only go up to 80, 90%, and that's what you seen on the last one. So we'll let this go for another probably minute and a half, and we'll see what the pattern is, and then we'll open the new battery and see how that comes along. Alright, so we got about probably 1 minute, and we'll see how this goes. Just the patterns, just to show you. And you can see those two top kind of meeting. It's kind of coming at the center. That's what you want. See, and a lot of people probably want to know this. How in the heck are you supposed to read this crap? What are the instructions? Like, what does this mean? But you can see it's meeting up somewhat. So this would be a good battery, and you see good rhythm here. And there's some batteries that you'll see this like jacked up rhythm here. I would like to show that when I got a discharge battery and show you guys. And probably I'll do a follow-up video on that, but you can see out of 1200 it's at 112 or 128 now, 7%. And you can see how, like, when you're working, you got your next phone queued and you're sitting there going to work on it. At a time, you can have the battery charged, and then after you come back and you look at the battery, you can see the percentage of the charge and how it charged to kind of tell if it's a bad battery, causing somebody to boot loop or have other issues with their phone down the road. Which the best thing is, you don't want to see a customer unless you have to see them the second time. Not fixing the same device, but fixing a new device that they bring to you, or a different device. Not the same. So that's what you want to see on a good battery. So this is a good battery. I would say this one's good. We could sit here and go back. 99%, 75 times. And this one has a manufacturer date of the 15th, 2015, obviously. And you can change the cycles, the time, and all that, but and the efficiency, but we're not going to do that. Alright, so what I'm going to do is I'm going to disconnect this phone here. Disconnect that, plug this back in. We're going to open this battery here from this company and we're going to see. Obviously you can see that you got to bend it yourself. That's usually a sign you can tell that you got a good battery or not. Now this one's manufactured in 2017. We can see 9 of 2017. So we'll look and see if the date is correct. And it looks OEM. And we have no bends in the cable, so that's the key right there. That's a big key. Unless they soldered on a new chip on the bottom, which is possible, so you gotta watch it, especially a lot of Chinese rehabs. So let me put this on the board. We're going to disconnect the power obviously first. Alright, so we got the battery on there, we got light, snapped into place. So this is pretty interesting here. We don't have an OEM battery here. Alright, so this is a new battery that I pulled out of the package. We have an iPhone 6. So that does not say OEM battery, does it? No. 0 times. 0% charge. Efficiency 101%. What's up with that? 1500 or 1560, 1580. So you're telling me this battery can charge more than its designed capacity? Does not make sense whatsoever. Now that could be the problem of exploding batteries too. I haven't put this one under test or this company under test, but I have heard of people saying that this actually battery does expand, and the same thing happens with the expanding batteries. And that was the company. So I have had a couple cases from this company where the batteries have expanded in the phone after replacing an iPhone 5C or a 5S battery. I think it was a 5S battery that replaced it with a new battery and it expanded. And you probably wonder why. It's because possibly that the capacity is larger than what it should hold in the charge cycle. So what we're going to do is we're going to plug this in and we're going to actually test the cycle of the charge. So I'm going to plug in power here. I'm going to go charge. And you can see it's charging now, 44%. And I just wonder why 101%. Not right. Let's go to charge cycle here. We'll give this a couple of minutes and we'll look at it. So we'll give this about 3 minutes. And then we'll check on it. And by the way, this machine does a lot more than just testing batteries. Does so much for the iPhone industry. Also, I just seen basically almost I think it's a data recovery option in the machine. I mean, there is data recovery option for the data chip and copying it and everything, that too, but there is another feature that maybe possibly with Android phones, which I'm looking forward to. I can see it in the new software update, which retrieving data from the memory chips of Android phones, which would be pretty awesome, especially if it's not encrypted data and you could retrieve that data and save somebody's pictures and memories for them either crushing their iPhone or Android phone or water damaged device or anything like that. Remove the chip and recover the data off it, which would be pretty awesome. Now you can see this has like a so much amperage. You see it's charging really high. So obviously you'd want to slow that down. And you see we just adjusted it. best thing would be to adjust it kind of midway. So we're gonna see what we get on this letter, this next pattern here. So we can just go down a little bit more. Because you can see it's charging the phone at a high rate, 48%. So it's kind of giving me clues that would you want to use this battery or not? No. I mean, it's at 49% already, and I just threw it on there. I mean, granted that we have high amperage, but we're going to slow the amperage down. And that's where we're going to want to be, right there. You can see midway. A little slower charge cycle. We don't want to be popping a lot of amps in there. So, I mean, yeah, this is the battery you could use, but I mean, the thing over the capacity limit is over. So therefore it would always charge the battery more than what it's supposed to do, which can cause an issue of expanded battery. So I'm thinking my theory is right on this. When you have this capacity that's over designed, it actually expand the batteries more because it's thinking it needs to be charged more. Then we have 101%. Like, I test a lot of batteries, I don't see this. So you guys give me a shout out. I don't know, like this company here, for some reason I've had a couple of bad batteries from them. Not many, probably out of like 10 batteries, 2 come bad. So, but I want to know this. You got the temperature of the battery, chip number, and the date, 2016. I don't even think I can remember the date when this was. You guys remember it? And we'll go back to the charge cycle. So basically we're going to charge this up. If we do charge it up all the way, we're going to get up to 1580, which would be bad. You don't want to do that. So this number would go to 1580, and then it max out and stop charging. So it's charging over its limit, what it's supposed to. And that's 2016. So it's a 2016 battery, right? You guys can see the date, manufacturer date, right? So obviously this is a lie. guys see that? 2016, 2017, 13th month, or not month, 13th day. So 2016 is the year and the day. And I don't know what this means, but obviously it's not 1996, so, or else I'd be like still younger. But yeah, 2017. What's that say? We'll connect it. This came out of the packaging of this battery. California. And you can tell it's not OEM battery. Now this company sells this battery as OEM, not OEM. If you guys feel free, you guys can contact me freely, this company directly, but I call this bullshit. And why I say that is capacity limit, the date, the manufacturing date, and also not OEM. What kind of crap is that? Now, I've ordered lots of batteries from this company. If I would have known this crap, I probably wouldn't have ordered it from them. But I just want to know what the reason behind this is and why I've got defective batteries, a few of them, ordering from this company. And now I kind of know why. Is because the capacity limit is different. It's not original OEM that they describe in their eBay account that they sell these batteries on as original OEM batteries for the iPhone 5S and 5C. They're not OEM. Let's connect the OEM battery just for shits and giggles here. Just show you what an OEM battery looks like. Let me see here. Here, let's grab another battery here. Let's try this one. Let's see if this one's OEM. This has got tape on it. Alright, this one's bent. This is brand new. Never removed the tape from it. It's the red tape. And this would be a 6S Plus. What's that say? What does that say? Now, this was supposed to be, you just see me rip it out of the packaging here. The packaging. See that? That's the packaging. New tape, red tape. If you guys get every red tape on your freaking iPhone, do not order batteries ever from them again. Alright? Real talk. This is so upsetting for repair communities. And people try to rip people off, and that's what's going on exactly here. So what we're gonna do is we're gonna go over this battery I just pulled out of packaging, just straight out of packaging. Never use this battery. I don't know what the hell that crap is right there. Marks from removing the iPhone screen, whatever. I don't know. But we're gonna look. Times charged 652. So this company sold this battery on eBay, but did not have a decency to sit there and say that this is a used OEM battery. OEM, original battery. So this is original battery. I gotta give them to that. You gotta give them to it that the design, see, it's the capacity is not over the design capacity. So that's a good thing. You can use this battery. It's a good battery. You can use it in customers if you want. But 529 capacity charge, no, I would not want to use this in a customer's phone. So you look at efficiency, 98%. That's good, but you really don't know that number until you're out there charging it. And you can see we got a 3% charge on here, and it's charging because we're injecting voltage into it. And this is the pattern that it's got right now. And you can see the voltage dropped, but we'll sit there and stop that start. But I just want to go back on this page here real quick while that is charging up. But OEM original battery, yes, it is OEM. It's original. It's chipped right. You can tell that some of the pattern was removed from here, from removing the battery, and you can tell this was bent, so you can tell that was a used battery, stripped out of a phone, resold on eBay as brand new, OEM, never used. So you guys kind of gotta watch what you guys order for part wise and stuff like that. I mean, this is crap. We shouldn't have to deal with this stuff in the industry. We should have the right to repair bill, and we should be able to repair these devices, order the parts from the manufacturers directly, and not get sold bunk ass equipment. Excuse my language. Wow. Whatever. Just it's bogus. You should not be getting sold crap like this. (2015). So we'll look at the manufacturer date on this. So you can tell this original battery, it's not legit. I mean, it's brand new. And 2015. So this was right on the manufacturing code. So now we see that this new battery that was sealed in a brand new case, and it's nice, and from this company, not OEM, not the right charge cycle. Yeah, we'll just plug it up again. I'm curious, just like, wow. That's how these companies are ripping you guys off. You know, I could easily just sit there and go, oh, here. Let's delete the counter time as charged. Ridiculous. So, if I really wanted to, I could contact this manufacturer. $525 times. 552 times. Sorry, my bad. 552 times charged. That's how many charge cycles this battery's had. And they're selling this brand new on eBay, OEM. Can we get OEM parts? No. We need the right to repair bill to pass. So we don't get duped like this. We don't get duped with time cycles, the percentage, the amperage, the capacity. Come on. This is ridiculous. So 2014 battery. $405. Original. Original battery, 2014. So your date codes, you kind of want to go off your date codes there. If you go off your date codes there, see how it says 10-2014, 10-2014. That's what you want to go off of to know if you have original batteries, not resold, the counter deleted from them and resold. And there's probably a lot of eBay and even Amazon sellers that are doing this, but it's kind of bogus. So I hope you guys liked the video on how to test the iPhone batteries, how to find out what's legit and not on eBay and stuff like that, and not get ripped off. I hope you guys liked the video. If you guys can, give this a thumbs up if you liked the video, and also subscribe, and thanks for watching.